Consider this triangle. They give you a triangle with ABC and they give you two sides. Select all the expressions that are equivalent to the length of AC. So they're asking you to find all the expressions that are equivalent to the length of AC. Here's AC. And I want to find out which are equivalent to that. First, it is best to find the missing length. And I'm going to use my Pythagorean theorem to find the missing length. So we have C squared is equal to A squared plus B squared. And of course, some of you guys have already memorized your special triangles, so we know that this will be a 4. Otherwise, let's go through the process. C is your hypotenuse, which will be 25. A is either the missing one or the one that's given, either one of the legs. In this case will be 3 squared, which will be 9, plus B squared. I'm not going to move my 9 to the left because I say negative 9. That gives me 16 is equal to B squared. So therefore B will be equal to 4. Take the square root on both sides, end up with 4. So therefore BC is equal to 4. Since they are looking for the expressions that are equal to the length of AC, instead of using the 3, I'm just going to use the X. It will be just much easier to process. And now you get to this side. Notice that they give you angles A and angles B. First, let's go and start with angle A. I want to make sure that I use my adjacent side first, the X first. So first, let's go and start with your X and your 4. If you're standing here, your 4 will be your opposite, and your X will be your adjacent. So therefore, do I need to use sine, cosine, or tangent? So, ka, do, a, o, a, o, a. So therefore, I need to use the tangent of A is equal to the opposite over your adjacent. But if you notice, there are no tangents of A. So I don't need to even solve for this. If you do solve it, you can cross multiply. So it gives you X tangent of A is equal to 4. And then I need to leave the X by itself, so I'm going to divide by the tangent on both sides. And gives you X is equal to the 4 over the tangent of A, which is not listed. But you don't have to go through this process if it's not listed. Now, let's go ahead and use the X and the 5. The 5 in this case will be your hypotenuse. So, ka to a. So, ka a. So therefore I need to use the cosine. Your cosine of X, cosine of A is adjacent X over your hypotenuse, which is 5. Now I need to leave the X by itself. So therefore I'm just going to multiply by 5 on both sides. That cancels. So X is equal to 5 cosine of A. So 5 cosine of A, it's located here. Select all the expressions. We need to continue on. Now let's go and stand up in the other angle. Let's go and stand up in angle B. If you stand up on angle B, this will be your opposite, your X, and this will be your adjacent. So let's go and start with that. Opposite and adjacent will be your tangent. So ka toa o a. So the tangent of B now is equal to your opposite over your adjacent. And different ways to solve it. You can cross multiply, or since the X and the 4 are dividing, I'm going to multiply both sides by 4. That cancels, so X is equal to 4 tangent of B. Let's see, 4 tangent of B is located here. And let's try the last one. I'm going to use the X. Remember, you always want to use the X because that's what they're looking for. Now I'm going to use the X and the 5. The X is your opposite and your hypotenuse. So, ka toa. So, opposite and hypotenuse. So the sine of B is equal to the opposite over your hypotenuse, which is 5. I need to leave the X by itself, so therefore the 5 is dividing. I'm going to multiply both sides by 5. Or you can cross multiply as well. Therefore, X is equal to 5, the sine of B. And 5 sine of B is not there. So So therefore your only answers are B and E.